Hi everyone, welcome to Mike Likes Robots, where we share knowledge to accelerate robotics. And I'm going to be changing the format of this series a bit. This is the Advent of Code series, and we'll be going on to video 17. Now, the idea was that I would only be making 1 hour a day, but as we've seen from days 12 and 13, that's not really going to cut it anymore. So from now on, I'm going to be dedicating one video to each puzzle, and I'm going to spend 40 minutes reading through the puzzle and attempting to solve it. Then I'll cut the video and I'll try to solve it myself off camera. And then for the remaining 20 minutes, assuming I do manage to solve it, I'll explain what I did and where I was going wrong. So with that, I'm going to go on to day 14, which today is called Restroom Readout. Also for the next few, I'm going to try and catch up at least one puzzle. So I won't be recording Facecam for at least this one and maybe a couple more depending on how far I get. So hopefully a screen record is enough. Okay, day 14, Restroom Readout. One of the historians needs to use the bathroom. Fortunately, you know there's a bathroom near an unvisited location on their list, and so you're all quickly teleported directly to the lobby of Easter Bunny headquarters. Unfortunately, EBHQ seems to have improved bathroom security again after your last visit. The area outside the bathroom is swarming with robots. To get the historians safely to the bathroom, you'll need a way to predict where the robots will be in the future. Fortunately, they all seem to be moving on the tile floor in predictable straight lines. You make a list, your puzzle input, of all the robots' current positions and velocities, one robot per line, for example. And it gives us a list here. There's a position of 0, 4 and a velocity of 3, - 3. Interesting. Each robot's position is given as P equals XY, where X represents the number of tiles the robot is from the left wall, and Y represents the number of tiles from the top wall when viewed from above. Left wall, top wall. Yes. Okay, so a position of 0, 0 means that it's all the way in the top left corner. Each robot's velocity is given by V equals XY, where X and Y are given in tiles per second. Positive X means it's moving to the right, positive Y means it's moving down. So velocity of 1 - 2 means that each second the robot moves 1 tile to the right and 2 tiles up. The robots outside the actual bathroom are in a space which is 100 tiles wide and 103 tiles tall. However, in this example, the robots are in a space which is only 11 tiles wide and 7 tiles tall. The robots are good at navigating over and under each other due to a combination of springs, extendable legs, and quadcopters, so they can share the same tile and don't interact with each other. Visually, the number of robots on each tile in this example looks like this. There's an example here. And then these robots have a unique feature for maximum bathroom security. They can teleport. When a robot would run into an edge of the space they're in, they instead teleport to the other side, effectively wrapping around the edges. Here is what robot P equals 2, 4, B equals 2 - 3 does for the first few seconds. So it goes, excuse me, it's at 2, 4, it goes 2 - 3 to here, and then 2 - 3 sets. 1, 2, 1, 2, 3. Here it is. After 3 seconds, it does another one, and then it teleports. Okay. The historian can't wait much longer, so you don't have to simulate the robots for very long. Where will the robots be after 100 seconds? In the above example, the number of robots on each tile after 100 seconds has elapsed looks like this. To determine the safest area, count the number of robots in each quadrant after 100 seconds. Robots that are exactly in the middle don't count as being in any quadrant, so the only relevant robots are... Okay, so we divide and there's 5. Okay, in this example, the quadrants contain 1, 3, 4, and 1 robot. Multiplying these together gives a total safety factor of 12. Predict the motion of the robots in your list within a space which is 101 tiles wide and 103 tiles tall. What will the safety factor be after exactly 100 seconds have elapsed? Okay, this is interesting. Sounds good. I can only think of just writing the simulation code and seeing how well we do. So I'm going to cut to when I've got a project open and we can begin to code. Okay, here we are. So I've created a test module with a test. I'm going to encode the width and the height into the simulation, into the restroom simulation struct, which I've yet to create. And I also need to create a part A for it. So I'm going to create some empty methods so that everything compiles, starting with function part A, which will take a reference to self and return a usize. We'll just mark this as 0. We're also, instead of doing from str as I normally do, I'm instead going to do from, just a from function, and I'm going to do custom parameters because I want to be able to pass the width and the height in, and that doesn't match the normal from str implementation. So for this, I'm going to take a puzzle, which is an and str, and then a width, which is, let's say, usize, and a height, which is also a usize. And I need to return a restroom simulation from it. Okay, so far it doesn't, actually we want to return a result of a restroom simulation and the error type. Let's take our parse error equals, I think this is a parse int error. Let's run that and it will be a parse error. Can't find parse error. Inherent associated types are unstable. I don't know what that means. So given that I'm not saving that many characters, I'm just going to move it there. And now it should tell me that it's not doing it because it found a unit type. Yep, that's what I wanted. Okay, now within my restroom simulation, I do want to store the width and the height. And I also want to store, what is it? Probably a hash set of robots? Hash set of robots, I think. That's probably the best way to do it. So let's use a hash set. Let's take our robots list, which will be a hash set, and it will contain a robot. Now we're going to need a robot struct as well. Which we might even be able to do from string. Let's leave, well, the structure should be position, which is a point, and velocity, which is also a point. But just because it saves a few characters, I'm going to shorten these to pos and vel. Okay, so we've got a hash set of robots, we've got a robot struct, and we've got a point class that it doesn't know what it is. So for this, we're going to need to add a dependency to cargo.toml. We're going to add path is equal to .. util. Is that okay? Then I should be able to use it. And there we go. That's it. Okay, I also want to use regex for this. So I'm going to, oops, ignore that. Cargo add regex to this. And again, it's just a case of running the capture. Oop, that didn't like that. Let's save. It needs to be source main.rs. There we go. Here we are, and we have got a bunch of parses. So yeah, we might even copy this system. Let's take that and put it here. And let's take this and put it here. Okay, now I don't need to parse this whole thing. In fact, I can just do 4 integers, but it's made slightly more complicated by the fact that I need to include negative signs. So let's take this lot and put it into a regex tester. Now I'm going to put \d plus, \d plus, And I can just repeat this until I get to a new line symbol. Now, these aren't working because I'm expecting to get a negative sign in, and I need the negative sign for it to work. Actually, this needs to be \s. There we go. So this is giving me -3. So I want to do -, which means 0 or 1, -, -, and with that, it did not work. So yes, this matches. I wonder if I can just, for each line, find any that match a thing. Can I do that? Puzzle.lines.map, take L, and we do an L.find pattern. Yeah, I'm not sure I can do that. Okay, that's fine. Let's get this working correctly. So I'm looking at the description here. It says minus matches the character minus with index 45 literally. That's what we want. 0, we want to match between 0 and 1 times. I think it's purely because of this greedy match before it. So maybe if I change this to a minus and an equals. Do I need that? I'm not sure I need it. Okay, so group 1, 4, 3, and -3. And then group 0 is the full thing. Yes. So this is actually what I want. So I'm going to take this. And then instead of machines, it will be robots. Instead of arcade, it will be a restroom simulation. This will be our robots, and then we'll be directly passed in the width and the height. Now our robots needs to be a robot, so I'm going to put this into impl robot. This won't be an anyhow error, it will be a parseInt error, and we will return a robot. Now we don't need AX, AY, etc. What we want is PX, PY, VX, VY, and remove all these targets. Okay, now AX, AX, VX, VY, remove these. Let pos is equal to a point of PY and PX. This might be confusing to you, and I'll explain why I'm doing it like that in a second. VX. In fact, no, let's actually do it X and Y. I think it'll match the puzzle better. It'll be easier to debug. The reason that I normally do it the other way is because normally you iterate from top to bottom, which is the Y coordinate. So normally you pass in Y as the major coordinate. So it is a bit confusing because normally in a 2D graph, you would have X along left to right and Y along top to bottom. But But it doesn't really matter which way around you do it as long as the maths matches up. So this is fine. I can return a robot. I can return the pos and the vel. That should now be happy. It is. Couldn't convert this to parse in error. Oh, yeah. Okay, that's a problem. In which case we are going to cargo add anyhow. Make this an anyhow error, which means that we can now return it. Great. So we've got this. This is our robots. We're going to extract them. We're going to filter them. Except this will be px, by, bx, by, and no targets. It will return a robot, new from struz, and again, ax, px, py, vx, vy, and no targets. There we go. Now we actually want to collect it into a hash set. I don't know if we can just directly collect like that. We can't do it because we need an equals for robots, which is fair enough actually. How do you know if it's already in the set unless you can check for equality? So let's go by that. That works because point already has partial equality and equality defined on it. It wants a hash. We can give it a hash. And then it's happy. Great. Okay, so that is our puzzle read in. We just need to give it puzzle here. And if we derive debug on our struct, we should be able to print it out as part of the test already. Derive debug. We're going to print it. Print it. Sim. Now part A is unhappy because I need to unwrap this guy. Okay, let's cargo test this already. And the test failed, like we expect, because it gives us 0. But does it print out the right thing? So it's a robot with position 10.3 and velocity. Oh, these are all out of order. Let's find the one with position 10.3. There it is. And the velocity is 1.2. That's not correct. It needs to be -1. Ah, this is a problem. So actually we are going to match it against the whole thing. And then that gives us the exact values. So that is because... Let's just run this and make sure it works before I start explaining why. Find that. Okay, 0, 0 has 1, 3. How's that? 0, 0, 1, 3. Let's find one with the negative. So 3, 0 should be -1, -2. No. 3, 0. Oh, there's 2 with 3, 0. There's a 2 -2, which is that one. Yeah. -1, -2. Yeah. So the reason is because when we had these greedy dot stars in, it would eat up all the characters, including the minus signs. So we were losing those. Even though we were specifying 0 or 1 minus signs, it was using them before. So by removing all the dot stars and specifying our exact input style, we don't suffer from that problem anymore. Okay, so we've got our robots, we've got our restroom simulation. Now I'm going to create a new function. It'll be called tick. So I'm going to call this, tick and mute self. It won't do anything, but on top of self, it does actually need to know the width and the height. Right? So it's not going to do anything. I'm just going to mark this as to do. Then we've got our from. We need our part A, and we're going to create a function which is tick n. This is going to need to be a mutable self, which means that part A will need to be a mutable self. And then we can do count in quadrants. And this can be immutable, and it will return a usize, at which point I will self.tick n 101, and I will steps is a usize, that's fine. Zero up to steps. Self.robots.iter. I would like to mutate for each robot. We're going to robot.tick. Width will be self.width. Height will be self.height. Happy? It is happy. So that means that robot must be a mutable reference, which is nice. Okay. Count in quadrants we've yet to do, so we need to do 0. So we're going to tick n, and then we are going to self-count in quadrants. And that will be our result to part A. This, yep, we need this to be mutable. And this... and mute r. Mute r. Remove this mute. Consider it to be an and mute. And mute robot. Is that allowed? It is not, because I need to iterate over the hash set mutably. I guess it doesn't need to be a hash set. We don't gain anything from that. So let's rewrite it to be a vector and a vector, and then we should be able to iter-mute. Then it's fine. And we don't even need to specify this type parameter. Okay, we've got tick n, we've got count in quadrants, and we've got part A. Great. So now we've still got the tick function to do, and we need to do the count in quadrants. So what we're going to do is let mute top left is 0, and copy and paste that a bunch. Right, bottom left, bottom right. For robot in self.robots, let halfway equals, so we're guaranteed an odd size grid. So we should just be able to do self.width over 2. Let half width equals that. Let half height equals self.height over 2. For robot in robots, if robot.pos.x up robot.pos.0 is equal to half width, or actually what we can do is match robot.pos.compare with a point. So it would need to be and point. This is a little bit of an odd way of doing it, but it means that I can write all of the cases in one line. Okay, so if it's equal, ordering, equal, and we don't care about the other side, then we return 0. Actually, we don't return anything. We just do nothing. Can I just return nothing? I think that's it, yeah. So ordering now, if the height is on the middle line, same thing. In fact, I can just code this in one step by doing, okay, so if it's halfway up the grid or it's halfway across the grid, left to right, then it doesn't add anything. It doesn't do anything. If it is, okay, we're going to need to do a lot of ordering less than, so we're doing the width, and the position is, wait, the position is its X. So it needs to be checking half the width. Yeah, that's right. X is across and it's checking, yeah, that's right. So if it's, let's do less, greater than, greater less greater. Okay, so if it's less, then it's top left, which means that top left plus equals 1. This would be that the top right is 1. Then we've got bottom left is 1, and bottom right is 1. Great. Now we need to return top left times top right, excuse me, times top right, times bottom left, times bottom right. Okay, and it's unhappy with this because these are U sizes. Let's just convert these to I32, presumably. What do we specify in points? I32s, yes. This is now also an I32. Then that point is okay. Ah, that's actually wrong. Okay. This is wrong. What this should read is match brackets robot.pos.0.compare with half width and robot.pos.1.compare with half height. Okay. Oh, I specified the same case here. Thank you, Rust. We can borrow this, and that should be it. Okay. So we're checking how many robots are in all the quadrants. The last thing that we need to do is write this tick function. Let's do that. So we're going to do let new pos equals actually, we can literally just do self.pos is equal to self.pos dot add self.vel. Point cannot be dereferenced. Can I overwrite it? Apparently, I don't know if that works. Okay, so what we're going to do is we're adding on the velocity. That should just work itself out, but there's another step, and that is to check whether we're now out of bounds. So we can do the wrapping separately. If self.pos.0, this is the x-axis, is less than 0. Actually, I think we can do some kind of weird contains, can't we? 0 up to width dot contains self.pos.0. Then we need to wrap it. This is probably easy to do as a set of separate functions. Let's just do that. So if.self.pos.0 is greater than or equal to width, then we need to wrap it round. I think we can just modulo it. Pos.0 equals self.pos.0.modulo with the width. And the same for the height. But instead of .0, it's .1. But we also need to check whether it's gone off the left or off the top. So if self.pos.0 is less than 0, then self.pos.0 minus equals width. In fact, we can do that here as well. Pos.0 plus equals width, except this is a plus and this is a minus. Okay, self.pos.1 minus height, and gonna plus equals the height. Okay, why is that upset? Because it wants an I32 as I32. Ooh, that's a lot of changes. Do you know what? I'm just gonna pass in an I32 instead. Oops, there we go. That should be fine. And then when we use it is here, we're just gonna convert self.height as I32. Right. We have written something. Let's just test it, and it took a long time, but it did pass. Like, that should have been instant. It should have been instant. But anyway, it passed, so let's write a main function. So this is, so factor of 12, correct. 100 seconds. What's the full grid? 101 wide, 103 tall. Check, check, check. Don't need to print line. Can't do that because input doesn't exist. Let's get our puzzle input. Oh, that's a lot of them. Okay. Okay, let's do that again. It's happy, cargo run. And we get a result way quicker than this. Why did that take so much time compared? Yeah, what is that about? The cargo test is taking longer than the full run with the big puzzle. Anyway, let's check this is the right answer before we go any further. Submit, and that's not the right answer. It's too low. Did I give it the right answer? There it is, and there it is. Okay. I think in the interest of having an attempt at part B within 40 minutes, I'm going to pause the camera here and I'll cut to once I've figured out what this problem is. Okay, so I managed to solve it and I did change quite a bit, but a lot of it I didn't need to do. It was kind of reattempts to do the same thing. The real reason that it didn't work was because I was doing 101 steps, not 100. When it says after 100, the 101 number that I'm sure I read somewhere was the initial second plus an extra 100 seconds. And that's all it was. So for cargo test, it still comes out as the same thing. It still passes, whether it's 100 or 101, which is why I wasn't catching it. So yeah, it's just 100 steps. Now what I did do in this process was I changed count in quadrants to be a static function that takes an iterator over points. I also changed the I changed there to be a function so that it does safety after steps, and I made it all immutable. So there's no mutable references needed anymore. In fact, we should be able to just do that. Part A doesn't need to be mutable. Just like that. Okay. So yeah, this whole thing is immutable, which should make it easier to go on to the next part, part B, whatever that looks like. So is there anything more that I need to say about this? Yes, so I changed how it calculates the ticks. So now I calculate a new X and a new Y coordinate. I use I64s to make sure it fits because I'm not sure if it's going to get out of range, because instead of repeatedly adding a number and then doing the bounds check, I do steps times the number and then do a single step of making it fit within the grid. I'm pretty sure this while loop could be replaced by a modulo. I think modulo of a negative number should go towards 0. That could be something interesting to check, actually. Modulo of negative. Okay, yeah. So I think I'm probably doing the right thing. If you know of a good way of making this a single operation instead of a while loop, please let me know. As it is, it doesn't really have an effect on the runtime. So with that, let's move on to part 2. Okay, part 2. During the bathroom break, someone notices that these robots seem awfully similar to ones built and used at the North Pole. If they're the same type of robot, they should have a hard-coded Easter egg. Very rarely, most of the robots should arrange themselves into a picture of a Christmas tree. What is the fewest number of seconds that must elapse for the robots to display the Easter egg? This is really interesting. Okay, let's have a go at doing this. I have no idea how long it takes, so I was thinking that I could print it out second by second. I don't think that's really going to work. That's a really nice part too, though. That's really funny. Okay. I've no idea how to test for this. I'm also not really sure how to check for it. So I think we're going to repeatedly do 1 and then 1. So when I do pause after, I do need this mutable function. So let's replace this in. So and mute self, because I kind of need to go tick by tick and check the value at each point. So that'll need a width I64 and a height. Actually, these can just be I32. No need. Height I32. It's easier if it's I32 because then I don't have to do lots of number conversions from the points I32s. Okay, so I can basically do the same thing here, right? Except that instead of steps, it's just. And then I don't need any of the I64 clutter. In fact, I just did self.pause is equal to self.pause.add self.vel. So that's this gone. And then I can do while self.pause is less than 0, self.pause. This needs to be self.pause.0, actually, self.pause.0. Then this becomes self.pause.1. Then we don't return the position. It's just a mutable function. Okay, so at this point, we'll do function part B, self. It'll return a usize. And I don't really know a way of checking what the Christmas tree looks like. I think maybe what I'll do is store 1,000 safety scores. So I'm assuming that for a Christmas tree, it's pretty evenly distributed, which would make the biggest numbers. So I'm not sure if there's a numerical solution for this because you do need it to be. I think we do need to be drawing it out. And I think we need to be looking at it. So I almost want it to just continuously print the grid out and then we'll just watch it and see. So we'll print the number of steps it's done out and we'll print the grid that is the Christmas tree. And then at the end, we're just going to return a number. I think I am just going to hard code it because I don't think there's a programmatic way of checking whether it's a Christmas tree shape. I mean, maybe there is, but I'm not willing to code it. So I am literally just going to do 0. Will cargo run? It gives us 0. That's fine. Part B. So this is definitely for the fun of doing it. So let's just loop. So this is going to repeatedly tick the whole thing. In fact, I will just create a tick function which takes an and mute self and returns nothing. And all this does is self.robots.iter mute dot for each. It's going to take the robot and robot.tick. Self.width, self.height. That's all. Iter mute expected I32 and value size. Okay, you can have an I30. You can have I32s instead, if you prefer. Okay, yes. So at this point, we're going to keep track of steps. We're going to say print line steps, and then the number of steps we've taken. Then we are going to print line, I guess, and then we'll need to convert ourselves into some kind of diagram. Oops. So let's do that, and then we'll need to create the self.diagram. Now we might need to create a delay between each iteration here. But we'll get to that. Okay, and then we actually need to tick. Steps plus equals 1 and sub.tick. That should do it. Okay, let's create a diagram. Function diagram which takes and self. And we are going to go line by line. So yeah, for y in there must be an easier way to do this. Can I do it to a point? I don't want to double iterate for every point in a grid. So let's say I go from top left to top right, and then the next row, and then the next row, and then the next row. I need to check whether a robot exists with that position. So here's what I'm going to do. I'm going to create a hash map. Let mute robot map equals hash map new. I'm going to do my standard thing, which is unnecessary, but I like doing it. Self.robots.iter dot for each. We're going to take the robot R and we are going to insert into the hash map. Insert. I'm going to insert the robot's position and the robot. In fact, we don't need the robot. We don't need to store the robot at all. We can just say robot positions. Let mute robot positions. Then we're going to insert them and it'll just be r.pos. And it can be a reference. Doesn't really matter. Robot positions, we'll import that. Why do you not like this? Because it wants a semicolon. That's fine. And then I want to return robot position so I can store it in robot positions. Now it's a hash set of endpoints. Okay, so now I will iterate line by line and then cell by cell and figure out if it's in the grid. So for this will be our, I guess if we go by column. So column index, actually don't need the value. Col index in 0 up to self.width. For row index in 0.self.height. Let mute diagram equals nothing. Dot string. Then let pos is a point of row index col index. Is that right? So this is our x. So we actually want the column index here and the row index here. If robot positions dot contains and pos, then diagram plus equals a dot. No, equals I don't know, a pipe symbol. There we go. Else diagram plus equals a dot. Great. Once we reach the end of the row, we do a new line. And that should be it. No, a diagram, return the diagram. Then we can return a string. Why is this not happy? Because it needs I32s. Check. Self.tick part B requires a mutable reference, which means sim needs to be mutable, which means, okay, that's it. Let's run it and see how we do. Hang on a second. So steps 475, steps 474, steps 473. Yeah, I mean it is doing it, but I could do with it going a bit slower. Rust sleep. Okay, we're going to sleep for, so we'll have it about 10 per second. Sleep time. Thread sleep. Oops. Thread sleep for sleep time. Let's do that. We can put this to the top. And format. Okay, let's try that. Is it slightly easier to see? It is, yeah, it is. Okay. What we might even want to do is create files from this so that we're not watching it go across a screen. Okay, I'm gonna stop here. I'll cut to if I find a good solution for this, and then I'll explain what I've done. Okay, so I have actually found the solution, which is amazing. It was great fun, actually. So this is a solution. Now the question is, how did I find that? Because I definitely didn't sit there and watch that scrolling past on the screen. And the answer is that I decided to start writing these out into bitmaps. So here's how I did it. First, I had a look for a Rust crate that would do a bitmap drawing. And I found one that's really easy to use. You just need to produce a vectors of bools, right? So we're already producing a string for the diagram to print it onto the screen. So all we needed to do was convert the code so that it pushes whether there is a robot at a particular position or not. With that, we can write the bitmap out to a file name, and I'm formatting the file name to include the step count. Now, if I run my previous loop and I run This is what I was running to begin with. We don't need this for now. If I run this and I see what it produces, we can start to have a look at some of the trees that are being produced. And you can see, it's a bit hard to see at this scale, but you can see that every so often there's a weird column one and a weird row one. So I can zoom in on these a bit, but you can see that it's sort of focused into a column, which is a bit odd. And the same for this row one here, sort of focused into a row. And I noticed these as they were being produced and scrolling down. I did let it go for a while. It produced thousands of images. And after a while of doing this, I decided to try and optimize a bit. So, oops. Let's get rid of that. Okay, I tried to optimize a bit. Firstly, I was running it in multiple stages so that I could have a look at the trees each time. So I started doing a skip. That's where I just tick and increase the step without producing a diagram. So that made it a lot quicker to get back to my previous point. Then once I'd done that, I decided to start looking at the columns. So I looked at the indexes of these columns. I took a couple of examples, let's say these two. And these are, I calculated 103 apart. So I took these, it's 103 difference, so every 103. So that's why I set my skip count to 103. I set the initial number to be the number of the first column, or rather the latest comment that I'd produced. And I started writing it into a different directory. I made a subdirectory for columns. I was planning to do this for rows and columns. As it turns out, it's not necessary, because when I opened the columns and saw what it was being produced, I suddenly noticed this little guy. There it is. That's our Christmas tree buried in there. That's so cool. So there we go. That's the right solution. Now, I was thinking that I could just hard code the solution and respond with it, return it straight away. But in fact, I would like to keep the correct solution. So the correct solution will be, can I do it from bytes? I don't know. Let's try it. So it'll be puzzle / Easter egg .bmp. Then I'll keep let mute steps. I will remove all of this, and I'm going to keep this function even though I'm not planning to use it, although I will wipe out this name. I don't think this is necessary. I'll just not run this anymore, basically. So this is kind of legacy. I'm going to push it to my GitHub so you can see what I was doing, but I don't need this anymore. So now I'm going to go back to my bitmap monochrome crates. So it's Rust bitmap monochrome. So it's super easy to set up. This docs.rs has BMP. And I originally went to the crate, which gave me this example block to copy. Now I want to use this, so I'm going to just copy this. And the correct solution bytes, I'll call this, and then I want to read it, and it will take a read type. I don't know if I can just do this from correct solution bytes. Is that allowed? No. Rust get read type from bytes. How can bytes be shoved back into a read implementing type? Have a look at the chain method of std.io read. So it's a handle, f1.chain. There's no way to do this with an original read object. I don't know what all of this is, so I'm just going to include. Instead, I'll just use it from a file. So let's go with this instead. File open. It will be puzzle. And then in both cases, I'm just going to I'll read it out. So I'll do a read Easter egg, and it will return a result of either a vec of bool or an error, which would be an anyhow error. Okay. Let's move these. I don't need correct solution bytes. This will be correct. These question marks should now work. And then I should be able to BMP read. What type is this? It's a BMP. Can I convert this BMP into vec bool? BMP read dot inverse normalize remove by border get. Can I do an as vec bool? Is that allowed? Wrap it in an OK. I can't believe this is even contemplating this. Non-primitive cast, no. So let's try and figure out how to make this. I want to get the vec bool back. String output, which implements display. No, BMP contains the data as a vector of booleans. Can I just read it out? BMP. I want read, write, new, height width, get, moldiv normalize, blah, blah, blah. Clone, debug. I think what I'll do in this case is I'll return it as a bitmap. And then it implements equals. So anytime I want to do that, found unit type. Can I return that? No. What does this return? Okay, that seems to work. So let's correct equals read Easter egg. This will be a restroom simulation read Easter egg. Now I am going to loop for each stage. I will write my steps plus equals 1 self.tick, right? So in this case, I will write it to diagram, function to diagram, which will take and self, and it doesn't need a step count. It will just return a result. It should return BMP. How about that? Okay, so I can take all of this and I can put it into there. Then I can just directly return BMP. So this will need to be a result BMP anyhow error. And then I can wrap this in an OK with a question mark. Brilliant. Now I don't need this. I can turn this into BMP is restroom simulation dot. Wait, do I need self? I do. Self dot to diagram. Then I can write it out, but I need to check it. There it is. And now it's happy on write diagram. So what I can do now is I can say let diagram equals self dot to diagram dot expect could not convert to diagram. If so this is where we finally get a condition. While self.diagram is not equal to correct. Steps plus 1 step self.tick. That's it. Return steps. Okay, so we know the answer is 17486, so we can run this. It's not equal to correct. So expect could not read correct solution. Try that. Panicked because it couldn't read the correct solution. It can't read ... puzzle Easter egg.bmp. Can I do it now? Yes. Okay, so it's working on it. I don't know how long it's going to take. Considering we already know the right solution, I am tempted to just return directly. So I think I am just going to do that. So let's just return the number after all. Okay, so I had a go at coding it. I'll keep this code in, but I'll leave it commented out. There we go. Now I'm going to copy this and actually check it's the right solution because it might actually be one off. Your answer is too high. So we actually need to subtract 1 from that, I think. Turn to day 4. So that'd be 17485. I have 49 seconds left to wait. So why would it be -1? Let's think about that. It might not be the first solution that's part of it. So hang on, let's have a look. It's 17486, 27889. So 17486 minus 27489. Actually, the other way around. 9 minus 176, which is equal to hyphen 10,003. Let's take a look at that. Is it in this directory? No. It is not. So in this case, let's actually do it. So we're going to do for something in 0 to, actually we can just self.tick n, tick n. And we're going to do 10,003. And then we'll do for index in 10,002, 10,003, 4 maybe? So at this point we are at 10,002. Well, we started at second 1, now we're at 10,002. So we're going to self.write diagram each time. Self.write diagram. Steps. This I'll change. Oh no, I'll just make it trees. Self.write diagram, steps. Let's run that. Expected G size found that. Just write 0. And we should have some new images. 10,003. Let's do a few either side of it. So up to 10,000. It's not appearing. It's really weird. Let's actually do this. I think I'm just going to go ahead and skip 8320. Your answer is still too high. Unbelievable. I mean, it must not be the highest solution with it. Okay, here's what I'm going to do. Going to delete everything. Ticks, steps will be 0. Maybe steps is 1. No, steps should be 0. I think it is 1 based for this, so I am going to do that. And then I will do steps plus equals 1, print line steps, self.tick, and self.write diagram with the step count steps. Okay, let's try and do that. And once we start getting up to 17486, it should be fairly easy to spot. So I'm going to cut until I find the correct solution. Here we go, got the right answer. And the result was because there was another tree that I'd missed. So this idea of using the column and the row method was just not the right one, I think, because this wasn't a multiple of, I think, either one. I'm not sure about that. But anyway, basically you do my initial idea instead of trying to optimize it. My initial idea of just generating a bunch of images. At least this time I had an upper bound. I knew that it was less than 17,487. So I reduced it. I set an upper bound for how many it could simulate. And so I was able to create enough of these images that I found another one buried in there. So I've created the new Easter egg.bmp. I also got an off by 1 error the first time. This should be 7083 because I set steps to 1 and it should be 0 to get the right answer. So with that, this challenge is complete. Day 14 complete. I'll be taking a look at day 15 next. Thank you for watching, and I'll see you in the next one.